All right, everybody, it's after 2 o'clock now, so we'll get started again. We're running a little bit behind schedule, so we're going to compress just a little bit. I just wanted to pull up this tag, or this branch in Samvera APIs. It was slide 49. The next thing we were planning on doing is adding this retrieve resource handler, which didn't exist yet. So in my local checkout, I'm seeing, let's see, just deposit resource handler. But I want to retrieve resource handler. So I'm just going to check out this branch, and if we take a look in there, in the simple dev directory, in the handlers, we have the retrieve resource. This is what we were going to try to create all by ourselves. The important part is, hey, we created a new file, and we return operations, new retrieve resource, okay, with the payload, with the data resource. The other change that was necessary is that in main.go, where we're setting up that handler, is we added that line 31 right here. That's the only change I think that was made to this file in order to make that happen. So basically, we're gonna cruise past slide 49, and now we're gonna move into Taquito, which is the other subdirectory that has a project in it. So go ahead and change into that directory now. So Taquito is more or less the same as simple dev, with just more stuff fleshed out in it. It has ideas about the database. So it has DynamoDB built in, configured for our JSON metadata. So in order for us to use DynamoDB locally, we need something called local stack. So we hope you got that downloaded with your Docker. So the AWS command line utilities that you get when you download AWS can point to local stack by specifying the endpoint, and then you can run the commands against the local stack. Local stack is just a clone of a number of resources that power AWS, and DynamoDB is one of them. So I just want to close this one out. Okay, so this is our Taquito project. It's a little bit bigger. It has some extra packages we didn't see before. It has DB, which is for connecting to the database, and it has data utils, and some AWS stuff. When you go into main.go, you'll see some other differences. Basically, in our main, what we do is we set up an AWS session first, then use that session to create a database instance. We also create an identifier service. This is just a mock service that would be like the thing that talks to our Node service or handle service, something like that. And then we do this create server, which is down here. And this calls handlers build API. So we moved out the stuff where it builds that API into the handlers. It's called right here, it's called server.go, build API. This is where we're setting all our handlers that we have. Any questions on this so far? So we're getting just a little more advanced. So let's talk a little bit about why we're using DynamoDB. It was basically just a simple choice for us to make. We saw like good results with people using it, and we were thinking, hey, we have JSON data, and DynamoDB uses JSON. It'll be great. And there's an SDK for Go, and if it doesn't work for us, we'll maybe look at doing Postgres as our fallback. Turns out that we could get it to work, but it didn't work as well as we had hoped because we kind of had, because DynamoDB has like an expected way you structure your JSON, which is not how our JSON looked. So we had like this whole like transform step in there, which we really wouldn't like to have. We'd like it more like Postgres, where we could be like, here's some JSON, here's a JSON blob, store it, and give it back to me just like that next time I ask for it. So DynamoDB is there. It works, but we were not like really super excited about those prospects long term. So let's go ahead and set up a local stack with Docker and Taquito. If you're running a Mac, first of all, make sure you have the Docker daemon running. So you can see mine is running. Docker is running. And then, whoops, once I have that, I can run this command here. And I'm going to do it in a different shell. Could everybody follow along on your own computers? And you want to see this line on the bottom, starting mock DynamoDB and ready. Has everyone got to that? Any thumbs up if you're there?
I think I'm there. Sorry.
Getting there? Yep. You're good? Good.
Still
Yeah, next slide.
This is different from what you should.
Are you looking at the
You're
looking at the PDF, which is not sorry.
That's all right.
That would have
Let me just store the Slack quickly for you.
thank you.
Excellent.
Are you good, Josh? Yep. Okay. Good.
It's not Docker run. It's Docker run. That's a better version of it.
You're doing these instructions. Yeah, I think what you want to do is just put on this.
It doesn't need to be running. Yeah, actually. I think you want to
Do Docker colon local stack / local stack. Okay, then this, sorry, Docker. Just the command I did up there, Docker run. Actually, I think someone posted it inside. Okay, so this Docker command, what it's doing, it's saying, make a container for these set of ports. The -e means set an environment variable called, where it says services equals DynamoDB. And finally, the last part is run the image local stack / local stack. So that's telling local stack to run only DynamoDB. That port range is a little bit inclusive. It has more ports than we need. We actually only needed 4, 5, 6, 9, but whatever. We've got that in that range. Any questions about that command? Okay. Looks good. Okay. So in another terminal, we have a makefile, or I'm sorry, we have a makefile in the Taquito repository. We're going to type make resources, and what that's going to do is run the makefile, the resources section, where it builds the table in DynamoDB. And if we hit enter, it should give us a bunch of JSON that says it created a table. All right, I think most of us are ready to move on.
It's on the machine, so not actually at AWS.
Okay.
Everything's still local.
So the next thing we're going to do is
It has to think.
interact with the Dynamo directly.
We're eventually going to upload into AWS.
And there's two ways of doing this. If you install the local stack, like from Python, you could use this command called AWS local. AWS local is just a command that basically calls AWS with the endpoint URL correct for local host. It just does these things. And then everything after is the same. So let's list the tables. I will not use AWS local this time. Okay. Oh. Why am I getting that? Oh. Yeah. I'm going to actually specify. I'm not a big. I don't have my AWS configured, so I'm just going to specify my AWS access key as an environment variable. And what's the other one? Secret key. And then I can do all this.
So you're still on local stack right now? What's your local?
Yes.
Secret number for access?
Yeah. So these are just dummy values, which is unimportant because we're just talking to local stack. So it's not really doing any sort of credential verification, but it's really grumpy when you don't have any credentials set up at all. So it says here, I have created a table name called resources, and that's it, just one table. And just for the heck of it, let's try this AWS local. I think then I just have to do DynamoDB list tables. Same things, but I have fewer things that I have to put in. So then I can describe my table this way, and it gives me a bunch of stuff back. Most of this is provision throughput, which is like how much they're going to charge us, how fast things are going to go. There's also the key schema, which is like what is a primary key to them, and that there's an index on this resource by ID and version. Oh, I'm sorry, that is the global secondary indexes. So these are our indexes. When we're going to do a query, we need to have an index on things. That's there. And you have to define anything that is going to get an index on it. So in our case, the taco identifier, which is like our internal identifier, then the external identifier, which might be like our Noid or Druid or whatever, and then version, which is just a number. Those are the things we're indexing.
Okay.
Everybody able to describe the tables and list the tables? Okay. All right, we've got local.stack running, we've got DynamoDB. We've generated dependencies. Let's start Taquito and call some routes using curl. So starting Taquito is going to be the same as starting simple dev. We can do go run main. That's going to work. We could also do go build, create a binary, and run the binary. Uh-oh. So this is giving me an error. It says the address is already in use, and it's already in use because I haven't stopped my simple dev. Now it's running.
So now if we go to localhost, it'll see, you can see a website.
Yeah, we should be able to run this.
So now we're going to run these sample curl commands against our Taquito. Again, it's going to use that. It's going to post that sample data for us. Oh, and that's what a panic looks like. Could not find region configuration.
Export AWS region, I guess?
Yep.
Okay.
So the problem there is actually in the server, so I'm going to need to quit the server and So again, this is just sort of a dummy value. I think it's just complaining that we haven't set one. Let's try it again.
Oh, is that what you
Oh,
said?
you gotta do an export anyways, where you can.
Oh, I didn't put that.
Oh, okay, so now I'm getting no credentials. Again, I just need to go ahead, quit the server. Set all those environment variables.
That should be, is that space or?
Yep, the blank space after the equal sign.
Oh, gee, I missed that. Yeah, no, it's not.
I think you need a colon after that if you're gonna continue.
Yeah.
No, you don't, never mind.
Okay, AWS local not found.
Super.
You don't have to use AWS local if you don't want to.
You can solve.
Just go ahead and use the AWS and then set the endpoint,
Okay.
just as you see
Oh,
here.
I'll drop the command in Slack.
Oh, let's try running faster. All right, it worked.
what a return.
We're running,
ID.
yep, and when it is all set up and correctly working, it should just return its
Because
ID.
we hosted the resource.
Okay.
All right, is anyone having trouble getting there? Stuck on something?
It's the second.
Yeah, we got that.
Region to local stack.
We had
Yeah.
trouble, but we are now there, so.
Okay.
Oh.
The curl doesn't need to do that, but when I launched the server,
Right,
I
yeah.
passed in
I ran into that earlier.
the credentials right here.
Oh, you can use local instead of local.
It doesn't matter, it's just checking that you set
Oh, I
something.
thought I actually had it connected in terms of the doc.
No, it's not really, it doesn't really use those credentials, it just is really grumpy if you don't provide them. All right, so now we got to the point where we could create a resource and we saw this identifier get returned. We should also be able to retrieve that very same resource. So you need to copy half of it from here, and then copy that UUID that we returned from there. And I think there was something at the end. Oh, and we're gonna pretty print the result as JSON. And then we should be seeing the same resource we put in coming out. Does that work for everybody?
That's what we got.
Got it.
What's the,
Okay.
region configuration file? So if you go to your AWS config file. Yeah.
I'm still getting an X-ray piece on 8080.
Do you have another thing running? Having trouble? Do you need more help? Okay. I'm gonna move along. Right now we have a deep dive of main.go and server.go. I think I already covered this. I'm gonna just refresh it one more time. So in Taquito, I said we had main.go much the same as we had in SimpleDev, but we moved some of the stuff into this method called handlers build API. And that happens to be in the handlers package in server.go. We do the build API, and this is where we're setting up all the handlers. It's like basically building an API, setting all the handlers to whatever they're supposed to be. Here we have 5 other handlers set up, so this is almost the complete system. Whereas before we only had the one. And are there other questions about those things that people wanted to know? Other than that, we're not doing much in main.go other than in setting up all our dependencies, which are the database, and injecting those into the handlers. That sound good? So let's take a look at some of those full handlers. So we just talked about the deposit resource, so we'll go ahead and start there. In the beginning, I said we always have a package that's required. We always import our dependencies. There's a few more dependencies this time because we have our database as our dependency. We have our validator as our dependency. We have our identifier services as a dependency. And then we're just storing them in this struct. We're saying, make a new instance of this struct. This is sort of like an initializer. Anytime it's like capital new something, it's basically just like an initializer in Ruby, where we're just like set up some stuff. And usually it's create a struct and return it. Maybe you put default values here or something like that.
Is that idiomatic for Go? Or is it?
I think it's pretty idiomatic.
Okay.
It's not part of the syntax.
It's not part of the syntax. This is just like, we're just making, it's just a method, like anything else. It's just the idiom is to use new. So, this is really good to avoid like null value problems you might run into, because if you use the initializer, you can make sure the initializer initializes all the fields to a same value, rather than leaving some value didn't get initialized and you have problems later on. So here's the structure that it initializes: database, validator, and identifier service. And here's that handle method where we're actually doing the request handling. So we'll just walk through it a little bit again. This is really similar because we haven't changed like the parameters or anything. We're just changing what we're doing with it. So we're going to start off by we take the payload, which is the JSON stuff you passed in, and it's going to do a cast. And it's going to say, hey, I'm going to cast it to a hash that has strings as keys, and the values are just object or interface, the interface type. And it's going to do a new resource. And that calls that data utils resource. New resource here, which is basically, hey, if you passed in nil, I'm going to initialize something for you so you don't get null pointer errors. But then it's just making a struct. And the struct has a JSON field, and we're making a JSON object out of the data. This whole JSON object is something that we came up with in Taco and put it in here. It doesn't really exist in, it doesn't exist as a library or anything, but we found that it's, Go isn't great at doing JSON manipulation. Like if you're used to doing Ruby or Python or PHP, it's like really good at doing JSON, and Go is just a little bit clunky because it is strongly typed and JSON isn't. Okay. So we're back, we're not back there. We are lost. So we're back in our deposit resource. My shell closes files if you don't need to change a file, so I have to change it a little bit in an inconsequential way. So the next thing we do is we say, given that resource you passed into us, validate it. And that gets errors back, and it says, you know, if the errors are not nil, then we're going to return a unprocessable entity response and exit the method because we're going to return it. And we're going to give it some errors. That error response we talked about before, populate that and send it to the person and say, we can't deal with this, something's wrong. So we're going to talk about these validators later, but we'll just go with it for right now. Next, we have this authorization service, and we say, hey, we're going to make a new authorization service with the agent that got passed in, and then ask the auth service, hey, auth service, can this person do this thing that they're asking to do? And that's just a Boolean value. This is totally modeled after can. So if you're a Rails programmer, you're probably familiar with this. And if they can't, we say, you're unauthorized. Return the unauthorized response and quit. So if they got farther than this, they must be valid, they must be authorized. Now we can start doing things like, let's mint a resource. And we're doing identifier service.mint. And in this case, our identifier service is just a stub identifier service that does a UUID. But in Taco, what we do is we use our actual web service that generates identifiers and call it here. We make this identifier service be a interface that has the same methods, whether it's called on a UUID generator or a remote web service. So all we have to do is change the value we're injecting to this method, and we're changing the behavior, whether it's calling a remote service or it's a local service. So we actually are creating two identifiers. The second one here, it's always going to be a UUID. The second one is our internal Taco identifier. We'd like to have a unique identifier for each object and each version, but our customers for this, they want to know that, you know, it doesn't matter which version it is, it always has the same ID. But as programmers, we like to have unique IDs for things. So that's what this second one is, where it's just making a UUID. Just so we know what the heck is going on when we're debugging and stuff. Okay, so finally we go resource. We call the method with ID on it, and that's a setter. So it sets the ID. And this is also a setter with external identifier, and it sets that ID. And with version, and that's a constant one, because this is a create, so we're on the first version. And then we're going to do a little JSON manipulation here. Like I said, this isn't, Go isn't great at doing JSON manipulation, but we're saying, look at the resources administrative data, and on its created method, or on its created field, set a timestamp. So it's similar to what we did last time, except we're sort of using this like hash-looking way of accessing that field now. And then finally we say, hey database, insert this resource. And if there's a problem, just blow up. More properly, we probably should have done return 500 error and tell people something other than stack trace. And then finally, we initialize that response object, which in this case is just our JSON object that we made. It's in the data utils package. And we say, there's an ID with an external ID, and that's going to be our payload. So then we say, we created it, here's the payload. I want to go through the validations right quick. So, actually I think that is in server. There we go. So, if you recall, in the deposit resource handler, the first argument was the database, we injected the database. The second argument we injected was the validator. And the validator is something that we had to create because you can't do all the validations that we wanted to do in the static swagger.json. We needed something a little more dynamic. We want things to say, hey, if this field was set to this value, then these validations apply. So for example, if the type of this object is a collection, then it shouldn't have a file attached to it, right? Or if it's a file set, it should have a file attached to it. Those sorts of structural things. These are things that you can do in JSON schema, but you can't do it in Swagger version 2. In their OAS version 3, you can, but our framework that we chose to use, this Go Swagger, doesn't support OAS version 3 yet, and I'm not sure if they actually ever will. It's much more challenging. Another type of validation we've been using with our this JSON schema is you can say there are prohibited fields, and that's one of the things we've done here. Like, you may not set this field, or that's a problem. So anyways, here's a method that returns a validator. There's the deposit resource validator. Here's that method. It says, hey, make a composite resource validator. And our composite resource validator is another thing we took from Valkyrie, where it's a validator that takes a list of validators and it calls all the validators, and if one is invalid, it just returns invalid. So it's sort of like an and of all these things. So there's the new deposit resource validator, and finally a structural validator. And all of these exist in the validators package. So we'll just look at the new deposit resource validator. So this says, basically initialize a list of strings that have files in them: deposit resource.json, deposit collection.json, sequence, agent, and these happen to be schemas. Then we're going to build the schema and stick that in the schema field. And when we validate the resource, that's actually the core method on validator, is validate resource. It's going to use that schema to validate the resource that was passed in. And if it doesn't pass, it's going to build an error and return that error. Does that make sense? So this is sort of like our second level validator, and it can do any kind of dynamic validation that we have. It could do any kind of semantic validation. The structural validator that we're using is the thing that says, hey, all the children of collections must be objects. All the children of objects must be like this, the part or file set. All the children of file set must be files, that sort of thing. So when you get identifiers in, it's going to actually be able to look up those identifiers and say, well, what type is this identifier? Is it valid or not? So we're doing kind of structural validations that not only depend on what you passed in, but also other things like the database being there, so you can look it up and say, is it right? Is this the right thing? So you can see we have a bunch of validations. We have them for the different action types and also the different structures for the different elements, like collections, digital rights objects, etc. Identifier and permission service. So I said earlier, we have two different services for identifiers, one that just is local and mints UUIDs, and one that's remote and talks to our remote service. In our identifier package, we have something called, or this is the first time I think we've shown you an interface. So it says there's a type of service, identifier.service, called interface, there's an interface type. And if you have all these methods, then you conform to this type. So the only method you need to be an identifier service is you have to have a mint method. It takes a resource and returns a string. So when we say new service, it actually is going to create us two different services in here, a remote service and a local service. And if you haven't set if you have not set this environment variable, it's going to default us back to the UUID service. And since we didn't set that environment variable, it just used UUIDs for us. But had we set that environment variable, it would use that address to say, oh, fetch remote IDs from this service at this URI. And the other one is permission service. Our permission service, very much the same. I don't recall where I have it right now. Authorization. In our authorization service, we do the same sort of thing. We define an interface and we say, in order to conform to the interface, you have to implement these methods. Can create resource of type and can retrieve a resource. And right now we just have it set up to be our dummy authorization service. Whereas when we have a remote service, there might be some kind of switch in there, again with an environment variable or something like that. So right now, here's how it works. It says if the agent's user ID is equal to this hard-coded one, then they're allowed. And if they're not equal to that, then they're not allowed. So it's really really stupid right now. Okay, I walked through the validators a little bit.
So Justin, I made some changes to the schedule as a proposal.
All right.
I'm wondering if at this point, if there are questions on the code or just to take stock of where we're at in the overall process. And then switch into a shorter version of the Docker containerizing of the API, have a break after that, and then get into the AWS deployment. Because I know that there was a couple people who had interest in AWS discussions, so I tried not to shorten that. How does that sound? Cool.
That sounds good.
Fine for me.
AWS is cool. Hear more about that.
Okay. So we're approaching the end. Docker for deployment. I heard there was a break at 3. If we want to, should we go a little longer? There might be food out there.
If there's a break at 3.
Coffee break.
Okay.
Should we do that now?
Yeah, well, let's
Might
break
not be
for,
there yet.
are people
3
okay
p.m.
for 10,
for
15
coffee,
minutes? And then we come back and it's gonna be a longer call to get through to the end.
Let's do I think we can do the Docker stuff first in like 5 or 10 minutes. Everyone's already got Docker running on their computer.
I already went, but I'll have Docker then.
Okay.
I think we should vote. Because we're libraries, so we gotta find some sort of process. There's no we can form a committee.
Dictatorial regimes, that's how they go.
No, that's okay, let's do the Docker introduction and then we'll break it.
Yeah. Okay. So Docker is like a lightweight, super lightweight system for packaging and shipping applications. It is lighter weight than virtual machines because it doesn't run on the hypervisor. It's actually putting these package processes in the kernel, in the Linux kernel, and so they're really lightweight and just a really interesting way of shipping applications. It's been around for 2015, was it 2008? 10 years now since containers happened. They're getting really popular. There's lots of systems out there to run them. You can run lots of them at the same time on your machine, or you can take these containers and break them up across multiple different machines. And the idea is that usually your containers are doing very small tasks, like one service per container. If you were going to run Samvera, you could probably put Solr, Fedora, Rails all in one container, but that would be the wrong way of doing it. Instead, you'd want to have a container for Solr, a container for Fedora, a container for Rails, and have this like little cluster of containers that talk to each other. It provides isolation. You can deploy them anywhere. That's about it. So there's two terms you really need to know about in Docker. There's images and there's containers. And what you need to know is that an image is basically a set of instructions for the machine. Or it is actually like a blown up machine that is serialized and put on disk. It is the file. And when you take that file and you blow it up into a container, if you inflate it, then it becomes a container. A container is a running image, a running instance of an image. Does that make sense? So on your host, your Docker host, you have the Docker daemon, and it has a repository of images. And when you say Docker run, it takes one of those images and makes it into a container. There's also a registry. So the most common registry is Docker Hub. You might have heard that. So if you build an image, you can push it up to Docker Hub to share it. You can share it like with your friends publicly, or you can actually put it in a private registry. Amazon has one of these. I think there's a whole bunch of them. Usually you have to pay for them at this point, but that's really good for, say, I want to register it somewhere so that I can put it on a bunch of my different machines. These registries also have lots of good starting points, like, hey, I made an Ubuntu image that's super lightweight, it only has the things you'll need, or it's pre-configured to run Python, or something like that, or it has FFmpeg. So it's got lots of good building blocks if you look at the registry. The Docker client, most of this stuff is just command line tools, and there's a few things we'll go through. The few you see here is Docker build. And what Docker build does is it takes a Docker file, which is a list of instructions, which tells us how to create an image. And then Docker pull, what that does, it says go to the registry and pull the image from the registry and put it on my machine. And this is the Docker run. And there's also Docker push to push things into the repository. Yep.
Just a quick question. One thing I've always wondered about Docker, and I know you said a great deal, is how do I know if I can trust an image on the Docker registry?
You can't. It's just like any open source project.
That's true.
Yeah, I mean, I think people have attacked images too. Like it mines Bitcoin when you run it. So that's why you might want a private Docker registry. And I think they're auditable in some cases because people are showing their source and their work, but yeah, there's a risk.
A private Docker registry is simply a place where you keep all your images. So once I have a library of images, I essentially have my own Docker registry. Is that how that works?
I don't know exactly. I think it might be more than that because I think it has like an authentication component to it too.
Okay.
Like, okay, so a quick Docker intro. I feel like we covered this on the other page a little bit more. You can save and load images to a backup on disk. I've done this before when we were in a low bandwidth situation. Like, hey, we all need these images. I'm passing around the thumb drive. You can grab that tar and you can load it, and this like actual backup becomes an image. Then you can run it, and it becomes a container. A container, you can stop them, you can start them, you can restart them. I think those are all self-explanatory. I've never used commit. Tag is just like give it a recognizable label so that when you look at that image, you can say like, oh, run the latest version of whatever, Nginx. And then build, the Docker file is a list of instructions, and we'll look at that in a little bit. Any other questions there? Okay. So when you have Docker installed, you get the CLI. And you should be able to see Docker info. And it just gives you like, hey, you've got some stuff. You've got Docker, it works. I don't think there's much more to cover on this page. Docker ships with an image called hello world, which is like the basic image that says Docker works. So if we should be able to copy that. Oh, and it says it couldn't find the latest locally, so it pulled it down from the registry. When it says pulling library, I think it goes from Docker Hub by default. The pull completed. Image has a SHA-256, that's how we identify images. That's how we know it's just like Git, where your Git has a commit hash. They have a SHA hash here. And then, so it downloaded the newest image, and then it ran it, and this is the value. This is what happened when it ran. So, and it's done. So you can list all the images on your machine by doing docker image ls. So that's all the images I have, which are quite a few. I guess not too many. I must have cleared it out. You can list all the running containers. So here it shows I'm running local stack. And then you could stop that container or restart that container. And I've never used ls-all.
Use that when you want to get rid of dead containers.
Oh, okay.
This way you don't clutter up your...
Sure. So it looks like there's a lot of like exited containers. All right, so this is just showing what we already have in our Docker file in the repository in Taquito. So you can open Docker file in Taquito and see the same thing as you see here, except this is only the first half. So a lot of times when you run something in Docker, you start with a base that's here, Golang Alpine. And Alpine is a Linux distribution that's like super lightweight and it's meant for putting in containers. They like stripped out all the stuff you don't need. So in your container then, it's running like this basic system, but the cool thing with Go is that we can compile our Go program down to a linked executable that doesn't need that system underneath it, so that our container is only running our program and not like an operating system like Ubuntu or Alpine, whatever. So if we were to do a Rails program in Docker, we have to start with Ubuntu and then our Rails stuff on top of that, which would make the image and the container large. With Go, we can skip that whole operating system step and just have our one binary running. The problem is we need to build that image first. So our first directions are like, we're just going to make a build environment. So we're getting Linux for right now, but we're going to throw it away later. I'll show you that. Then it says, hey, we're going to work in the Taquito directory. We're going to copy all the files from that directory into the image. Then we're going to run a bunch of packaging stuff, like get these things, run that det command we saw earlier. And once we've done that, we're going to run this program. These flags here, I'm sorry, this is actually expanded in our Docker file, we compressed it here. But what it's going to do is build our binary with these flags that say build it for Linux, and the CGO enabled means that it doesn't need to have the underlying operating system for it. It can stand alone as a binary. So that was the first half, and then here's our second half. It says from scratch. That was also the first line up above. This means from nothing. We're going to expose the port 8080, and we're going to copy from that other image we made, the certs, and Taquito, and we're going to run .api. So before we built API, and now we're just going to run API in this container. And there's nothing in it except for the binary, basically. Yeah.
I've got a quick question on that.
Yep.
When the Go binary is running, since it's not running on a container that you specified a version of Linux, what container, where does the container get its, what container is it running? Is it just running in the, whatever version of Linux that you have to run Docker on top of, or?
Yep. No. It actually doesn't have an operating system. It's as if you compiled a program. This depends how old you are, but did you ever have an Apple II? You'd put in a disk, and it would run a program, the one that's on the disk. And we're basically doing that.
Okay.
We are just running one program without any sort of operating system underneath it, which is cool. It also has drawbacks. We can't do something like, hey, operating system, tell me the files in this directory. It's like, there is no operating system. That's not going to work. So as long as we avoid the things that would call down to the system, we're in good shape. So yeah, there's nothing running there. There's only one process in the container, and it's this.
It still needs to know an entry point, though.
Yeah,
But
but
that's all taken care of.
that's provided like that.
And you don't need to tell the container that built the binary to close itself. It automatically closes once it's done running effectively.
Yes.
The Golang Alpine, like as soon as it's built, it just,
Right, because it's done.
okay.
Yep.
Because it's just the one thing, like when I ran this, it timed out trying to do like create things because it didn't have Dynamo.
Okay, it shouldn't, but it might be a routing thing.
Well, I mean, where should Dynamo be running?
I think what we're going to have to do is you have to give it instead of localhost, because it won't be localhost anymore. And in the Docker route, you'll have to actually give it an IP. So the IP of your machine will probably work that way. So let's go ahead and build this on our machine. So it's Docker build, the -t, that's going to give it a tag. We're going to tag it taquito, and we say this directory. So here's the Docker file. If I do cat Docker file, you can see it's exactly what we were just looking at. We can Docker build -t taquito. That was fast. Yours might not be as fast if you didn't do this already last night. Has everyone got this far?
Over here.
Okay. Then we can run the container. Docker run.
I got an error.
Uh-oh. -p says forward these ports. And I'm using that tag. Oh, I got an error too. This one says the port is already allocated. And that's because,
Do we focus document?
no, it's because this is already running over here. So I need to terminate that program I already had. And then if I Docker run, it should look like it's up.
Invalid reference format.
Valid what for me?
He's got an invalid reference format error.
Yep.
Okay. Well, let's go do our break now.
Oh,
Does that sound good? All right, so once you have it running, the last command on the page to run there was a curl HTTP localhost, not local stack, which is what I tried, 8080/v1/health check. And this doesn't have any dependencies, but we're just showing like, hey, you're actually hitting the thing that's in the container. So I'll go ahead and do some sample test calls. So Alex, this is one you found, right? Like, hey, if you do this,
No, that's the region configuration. Mine was just, it would just time out because it could never hit.
Okay.
Here you did all those ethernet.
that, like this. That was kind of fast. Oh, no credentials. This. So one thing that Alex found was that if the DynamoDB endpoint environment variable isn't set, it uses the default, which is localhost, which is local to that container, and it won't travel out to your machine to your local stack. So you have to find the IP of your machine and pass this configuration in as an environment variable. And so you do that with a -E. The environment variable name. Here's my IPv4 address. I'm just going to grab that port. I forgot what that was. 4569. And I think when we run that, and you can see it's echoed what it said it's going to set. Then we're able to create it against our local stack. So just so it sort of has a networking problem when you use localhost, because it's not localhost anymore. So this pattern of like passing lots of environment variables to containers is pretty common. It's kind of ugly, and it's nice to have a way to manage that, like a makefile is a nice way to do it, or something else. But it's actually good because that means you can take this image that we're running here for development kind of locally, on our local Docker, and we can deploy that in production, and we don't need to change any of the code. All we need to change is the values of those environment variables, and then we can just manage that. There's also like a .env project out there. You might be able to use something like that to manage this. All right, so is everybody at least able to do the health check on the Docker server? Anyone not?
Still building.
Still building? Okay, we're probably gonna
Just
keep
go
going.
on without me.
Keep
I'll,
going.
my version of Docker was slightly older,
Oh,
so I didn't
Yeah.
downloading Docker took until fairly recently.
it's like 500 megabytes, yeah, it's
All
huge.
right. So just a few notes about our Docker development. We use Circle CI for doing continuous integration, and in doing so, it builds these Docker images and actually runs them and actually tests it against the image. If it passes CI, it pushes that image into S3 for us, and we have CloudWatch, I think? CloudWatch triggers off that and can actually deploy that image into our ECS, which is the Elastic Container Service, which is where in AWS you might run a Docker image. That's cool, because then we have continuous deployment. Whenever anyone pushes the merge button and the tests run and they pass, then that will shortly be the code that goes into production automatically.
So that was something you couldn't do with Travis?
You can do it with Travis. Circle CI is a little bit more geared toward using Docker and having images.
And the Circle CI syntax for writing those steps is actually much more Docker syntax-like, which is another reason.
I'm almost certain you can do the same with Travis. It's just that when we had a greenfield thing and we were like, make a choice,
Yeah.
why not use that one? It also tends to be faster, I think. So we did a coffee break, and now we're into AWS, the last star of the afternoon. Woo!
Made it.
I gotta put that one.
Use that too. Okay.
okay, my resolution is way less. What happened with that? Okay, AV.
Just do just something else fast. Was testing your eyesight.
Okay. Yep. Okay, so going over the AWS infrastructure, obviously everything we've been talking about today has been mirroring what we're going to do up in at the actual AWS cloud locally, but you need to get it up there. And we're going to follow through applying this infrastructure. It's a little harder to see. We're going to follow through creating this infrastructure on the command line. There are a handful of ways to deal with AWS. You can do command line, you can do the console, the AWS console, you can do Terraform or CloudFormation, whatever. Console and command line aren't necessarily the best ways to do it, but if you're going into something like Terraform or CloudFormation, you really should be familiar with the command line because it mirrors it very closely. And as far as AWS is concerned, the resources that we're looking at and need, based on what we've been doing throughout the day, are the pieces that are within this VPC, which is there you go, and then I'll just slide out of this. Which is a VPC, virtual private cloud. Essentially what that says is that everything within that cloud can communicate with each other, but not outside of the cloud unless, and some of them only if you specify that it's public and it can be communicated outside. It's a security layer. And then when we look at ECS, Elastic Container Service, we've got a couple pieces here when we use Fargate, where we have a service that defines how tasks are run and the resources that are used, how they scale, whether you add tasks or drop tasks based on load and all that stuff. And then the actual task is just that container. So we'll go through each of those pieces. And what we need to know as we're using AWS are we using the appropriate task in ECS? Can we connect it to Dynamo? We'll see if we walk through that. And then the most important piece is the IAM roles and policies. One of the biggest struggles you will find when you're working with AWS resources is if your roles or policies are misaligned, those services will just not communicate. It's basically how they firewall between the resources is between those roles and policies. You can do it by like CIDR blocks, and we'll see what that looks like. But the preferred best practice way is through roles and policies. And if you miss those, you just get timeouts, or you just get rights turned off or something. So we'll walk through each of those policies, and we'll do that by hand. And then after we build that, we will deploy that Docker container into our task, and we'll see the health check endpoint. So has everybody gotten their free AWS account?
Yeah.
Done your local configuration to get your local profile? If you've done your local configuration, you should have a file in your .aws directory called config, and then a file called credentials. Credentials has your AWS access key and your secret access key. And then config will have your default region.
And if you happen to set any environment variables earlier, like AWS region equals local or something like that, you'll want to clear that out.
Right.
I believe the credentials file can also have the config variables.
Can have that
So
there
you
as
can just
well.
have them under one file.
Yeah. If you don't have those and you run into errors like you need to define a region or something, you can do that in the command line with ---- region or through an environment variable or something. Okay, and we'll go through that. So everybody's got that set up? Thumbs up? Cool. Okay. You should be the admin on your local account, obviously. We won't do much with your admin account other than create the roles. You don't run your services as your admin account, you really just manage your account with your admin account. We won't go into it at all, but best practices, you dole those admin tasks out to other roles so you don't do much with your root account, because people have been known to lose their entire infrastructure because their root account gets hacked or whatever. We'll review our ECS task. We'll, as mentioned, with sort of firewalling between services, so security groups are applied to resources and they tell the resource what the ingress and egress policies are for that service, and that can be based on CIDR blocks, so you can say, like, this IP can get into a service, or the security group can get into a service, so we'll go through all that. We'll create the cluster, and we'll launch a container and the resources related to it, and make sure it's running. Okay, so this is what we should have done already. I will probably have to make this larger, as I always do.
No, it's just fine back here.
Can you hide the doc?
Can I do what?
The doc was kind of.
Oh, yeah. Let me just shrink this a little bit, and I should probably, I should probably fix my shell, but let's see. My shell's messed up. So AWS version. It's going to be all wiped out. So everybody should have something along the lines of 1.15 or so. I don't know if it's changed recently.
I think it's 116 is out.
Yeah, I think it
And
should-
that
it
works.
That works well. So make sure your configuration is set. You can see what's there with AWS configure list. And there's my set of stuff. Let's see. And then if you do right now, if you do AWS ECS list clusters, oops, not with the X, you should get an empty list, obviously.
Is anyone having trouble getting this?
Those commands are you able to run the commands like AWS ECS list clusters without profile or region? That should tell you if your profiles are set up properly.
You guys good?
Thumbs up? Cool.
Like that.
Okay. That's a good sign that your profile, that you configure your profiles properly. Okay, so we're going to go through some commands now, I think. And if you pull down the repository, you will have, how do I get out of this guy? There we go. If you pulled it, if you've been using the repository all day, you'll want to run these commands right now from inside the AWS directory within our repository. One of the other odd directories that we have there. And the reason is that we've got a few files in here. Instance role, trust policy, task definition, and user data. Those files, we'll look at those in just a second, but you need to be in the directory for those, and you'll see the commands here for what's there. The first command we're going to run is to create a role. So if you look at this command, it's AWS. You can set the profile if you need to. IAM, create role, give it a role name, and assume the role policy document that is defined here. So instance role policy, trust policy. This is what most trust policy or policy documents in AWS look like. It's got a version, a statement, whether it's an allow or deny, the service that it uses. So here is the principal and the service, so we're looking at EC2. And the action or set of actions in this case is assume role. And so what this policy document is saying is that we're going to create policy, we're going to create a role with a policy that allows it to assume the role for the resource that we're going to assign it. So let's go back and just follow along the repository with the commands. AWS IAM create role with that file. And I'm going to change the name because I've already done this. So you should get JSON like output that says a role was created. And it should look very similar to our policy document, but now it has a role ID and a role ARN. So you'll notice this format throughout AWS resources of ARNs, where it's ARN, AWS, IAM, a user ID or a role ID is what that is, and then what you call it at the end. You'll see that a lot throughout what we do. Did everybody get that output?
What was the command again?
AWS create role. It's the first one in the top of that README.
Just pick that one out.
Except possibly dropping the profile flag.
Yeah. I just dropped the profile flag.
Profiles like allow you to have multiple sets of credentials. So if you're like work profile or home profile, whatever, client two.
Like something or?
Aaron just dropped it because he's just using the default profile.
The dash dash profile with your profile name if you name it something else, or it's not your default.
Okay. Profile name cannot be found.
That means you specified the profile name flag and you probably didn't want to have it.
Okay, something on profile. Oops.
Sorry, yeah, when I wrote this, we had just shipped our Ops setup of AWS to start where a user has to assume roles explicitly in order to do stuff in various environments. And as a best practice coming out of that was the explicit use of profiles, where I'm acting in the developer role in the dev environment, and I'm acting as the administrator role in the user environment and stuff like that.
Yep.
But for most of you guys here, you're using your default, so you can leave it off. But yeah, sorry, it's in there. That's why.
It's fine.
So we take off the
Dash dash profile.
name and the IAM?
No, IAM is the command you actually run.
Oh, okay.
So the format of an AWS command, as you can see here, is AWS for the command line, and then the service or the resource that we're interacting with usually. So AWS IAM or AWS DynamoDB or AWS EC2 or something, right? So we're interacting with IAM, we're just dropping the profile.
And it worked.
So we've created a role. We're now going to attach that role policy. We have a policy document here. So these are static arms for different policy services. And so here's like the ECS container service for an EC2 role, the EC2 container service role. So we've created a role and we're attaching other static policies to that through the same command structure. So AWS IAM attach role policy. Just copy this command over. And I think I need to change that right here.
What do you do?
Oh, there we go. We're just attaching that. You don't get any feedback here, it just works. Or it errors out, like that or something. So we're going to do 2 of those. We've got to attach those policies. Everybody there? Pretty easy. Now we're going to create a profile name. Sorry, not a profile name. We're going to create an instance profile. Already exists. again, you see that ARN output in your JSON, you should get that. And we're going to add a role to that instance profile, which is the role that we created before. So we've got an instance profile, and now we need to attach the role that we've created, we've attached policies to, and we need to add a role to that.
So you need two twos in there.
Yeah,
Profile 2 and role 2.
I think I can do it either way, but
Yeah.
that's another one we won't get in the output. So one of the things that I like to see like at about this point when working with AWS CLI is also think about what it would take to do all this in the console, like all the random clicking and stuff that you have to do. If you at all familiar with getting started in the AWS console, you just click it all over the place, you have windows open. Command line makes it a little bit easier. Other things make it even easier than that. So now we need to create a key pair. And the key pair that we're creating is used for actually SSHing into an EC2 instance. So when we've got our EC2 instance running, we're able to SSH into it. And the way we authenticate is with a local key pair. So we need to create that key pair. And we can do that with AWS, EC2 create key pair, EC2 key. And you get this big dump of stuff. The hard part here is actually that we have to edit this, right? To save it to a file. We can't have new lines in there.
Right. What if you pipe that to JQ?
To JQ.
What if it work?
Let's see.
Or JSON PP, rather.
So, I'm going to duplicate already.
Nope, that was not quite as cool.
So,
Worth a shot.
yeah. Drop this into your editor. And change all the new lines. That'll even work. I think that's gonna work. Should get that in. These are all about the same position, right?
Or we could do Ruby -E puts that string.
Where are we gonna put this file?
You're going to put it in the directory that we're in.
Just in that EC2.
Yeah. You can just save it as like EC2 append or something. Well, just leave it on. Okay. So that guy. Now, the important part with a key pair file is the rights on the file, because it won't allow you to log in with a key pair that is publicly accessible. So you have to turn off any public read to that file at all. So I called it EC2-rollout change mode 600 roll.
It's actually French, it's schmo.
Oh, he's ES too, right? And you can add that key to your SSH file. When we come back to, later on, you'll see when we actually SSH into our EC2 box, we'll use that key. Okay, so that's there. Now you should be able to run, everybody get their key generated, edited, sort of?
You took out all the new lines and
Yeah.
you take out the prefix and post.
No, you need those in there.
Okay.
Everybody have
Did you have a
that?
question, Josh?
Their key.
You good?
I was just
Thumbs
on my
up.
side.
Good, cool. So now we'll run describe VPCs. You should see a default VPC with an internal slider block. And we're going to create a security group within our VPC. So you need to take note of that VPC ID that was just output. So in my case here, it's VPC-68AE7012 up at the top. You guys should have a different VPC ID on the phone. Otherwise, it's all weird. So take a note of that. And we're going to create a security group for that VPC. And nope, use a file for this guy. I've already got that guy. Get group ID. So now what we have is an empty security group. So we've created a security group within our VPC that really has no rights or rules or anything attached to it. We now need to configure that security group with ingress and egress rules. And it's important to understand that there are both that need to be configured, because you can configure a security group with I'll open up report 80 and it needs to communicate with the database, and you didn't egress that to the database or something. So we need to set ingress and egress rules. Take note of the security group ID that came out and run this EC2 authorized security group ingress for port 22 and port 80. We're just going to open it up and change that security group ID to the one we just generated.
Do you know if port 80 is open by default?
It is not. The only one that gets open by default is if you create an EC2 instance and use the default security group, it opens 22. That's it.
I think I ran something on the console and it already had 80 there,
Yeah.
but it might just because the console was doing extra commands.
Right. So we're opening 22 and 80 for the world on this particular security group. Now, so far, we've created a security group and we've allowed world traffic on it for 22 and 80, but we haven't, and it's within our VPC, but it's not assigned any resources. So right now, it's not like it's a problematic security group, because we haven't done anything with it that might open up a resource to the world. It's just a rule we've defined at this point. Everybody there?
Still trying to get my keys in.
Okay. Oh yeah, a lot of new lines.
Yeah, so I just replaced those new lines with real new lines.
Yeah.
Yeah, okay, so it's still coming into valid.
We should replace them with no.
Well, I did. That works.
Anybody else still stuck there?
I replaced mine with no.
Oh, so you can make that one complete line.
I don't know if that worked for me.
You make a copy. That's not at the end
So we need, obviously we're working with ECS, we need a cluster, so we're going to create a cluster. So that's a quick command, AWS, ECS again, AWS, the service we're using, create a cluster, and give it a cluster name, Keto, and we've got a Keto cluster. Quick. And you'll notice there's nothing in there, right? It's active, but there's no tasks, there's no running tasks, there's no active services, there's no registered containers. But we've got an ARM for it, we've got it generated. So now this one can be a little tricky depending on rights.
Yeah, you got one too many words in the beginning.
Oh yeah, thank you. I was looking for that one. So we're going to query the SSM service for the recommended AMI image that we're going to use for our EC2 instance.
Do you know what SSM stands for?
I don't know. Do you know what SSM stands for, Christina?
No. It's like, is it like systems manager or something like that?
Maybe, yeah.
AWS Systems Manager Agent. I
Okay.
don't know how I got two S's out of that.
Right.
Systems.
Oh, Systems Manager, the agent is not, wow, that's terrible. All right.
So one of the things to be aware of is, regardless of what you're doing with ECS, it's using all of AWS services under the hood for its pieces. So EC2, S3, storage, whatever it's using for that stuff. So what we're doing, and with Fargate, it hides a lot of that. With old school ECS, it doesn't hide that.
And we're using the old school version because it's available on the free tier.
And so what we need is an ECS, an EC2 image that is optimized for ECS. So that's what this AMI ID is. So image ID right here, AMI dash, that's the ID we want. That's what we're looking for. And you'll see in the next command, we are looking for, we've got a big chunk of stuff that needs to be assigned here. So it would probably be a good idea to pop this somewhere and copy and paste stuff. So right here is the image ID which we just queried for. Where'd it go? Here's this AMI ID. Too many editors open. So we want a micro instance. We are giving it our key name. Maybe wrong. CT-key2. Give it our security group, which is the security group ID we just set up before. And sign these egress, and here's our security group ID that we generated earlier. That might need to be a list. And then we've got a file, userdata.txt here, and associate public IP address. That tells it to give it an IP address so that you can connect to it from outside of the VPC. And if we look at the userdata.txt file in the repo, it's just moving over EC2 cluster equals Taquito into our ECS config. And let's run that command. And there we go. So we've got now a big output of an instance. No public DNS name yet. So if I go into the console, which I probably need to log in again. Or maybe not. Let's see. So you notice, you should see this if you log into your own console, that the status is initializing. This takes a little bit of time to actually build the instance and build the machine. So it says running, the state is running because it's actually started up, but it's in the initializing state right now.
It says it's running because they're building you.
Right, because they're building you, yes, exactly. Did everybody get through the ECS command there? The create instance command?
Still working on
Okay, I finally got my keys in, but I'm not getting an ID when I try to execute create security group. I don't need to give it.
Okay, you're right over.
Oh wait, I got now the group ID. If I don't have the VPC ID on the end, is that significant?
Which step are you running?
On 9. No, is it 9? No. I'm on step 6. I don't have a VPC ID to give it.
Oh, the step above that is what describes your VPC.
I get an empty array.
You don't have a VPC at all?
Just put in a create default VPC command.
Yeah.
Okay.
See if that helps you out.
Where? Okay. 10. There we go. Thank you.
So I'm still initialized.
Operation not permitted.
Everybody else sort of in that area? What's up?
Let's see what happened here.
So we're running an instance. We got our instance ID out here. And we want to describe instances. So if we run the command AWS EC2, excuse me, EC2 describe instances, dash dash. There we go. Instance IDs, the one we just grabbed. So you can kind of see the same status. It's got the attached stuff. It's got a private IP address right now, private DNS name. It's in a group. You see our security key, public DNS name. It doesn't say what the status is. Okay. So we take at the very top of this, we take the public DNS name, and we use that key that we created before to SSH into there, so SSH minus IEC2 key. Minus the pen. And then the user is EC2-user. That tends to trip people up sometimes. Is the user to log in as EC2-user at our public DNS name. It will ask you if that's correct. And we're on a shell on our EC2 vault. So, so we've got an EC2 instance running. We're going to attach container to attach to that. Are we mostly all there?
I found out my problem. I use my personal AWS account, and it's a classic account, and it's not compatible.
Yeah, there's a little bit of change to that. If you've had it around a long time, there were some recent changes to that I think you might have to call them or something to
Yeah.
switch it
I'm
over.
hunting around to see if there's a way to do it online.
Okay.
You can contact their customer service online, and they'll switch you over to running. But it can take a little bit of time. Like, it might not happen right away.
Yeah, okay.
So let's confirm that our instance is attached to the cluster. So we run AWS UCS list container instances for our cluster to Quito. Oh, I'm still holding. You don't want to do that from the shell, you want to do that from local. I'm not seeing mine attached, so why is it still initializing me? Let's rerun. I'm not seeing it can attach to that. We'll see what happens. So we need to create a task definition for our ECS cluster. That task definition is in task definition at JSON, so if we look at that here, again, one of the files that's in this. You notice this looks a lot like stuff that's in a Docker file. So it has a lot of the same stuff. We've got our named taquito, our CM Harlow image in the Docker Hub, taquito latest, some CPU settings, the 8080 port, the host port of 80. So once running on a container, what we're opening to the world, and then some environment variables that will be set. So region, you might want to change that because we use a different region. I'm in a different region. You change that to whatever region you're in. And then what the table is. So I'm going to change mine to we want to create that task. So we're going to register that task definition. Yes. And we get another chunk of JSON output. Again, checking in the console. There's our taquito. We have a task definition. And then, so we take that. Okay. So that task definition that it dropped out here, again, we use that in our command here, where we're going to create our service, so ECS, create service. Desired count 1. I'm going to drop this back into the editor just to service name taquito, cluster taquito, cluster definition. I need to grab that definition arm, which is right here. Task taquito 1. Desired count. Run that guy. So now we've got cluster, the task definition, the service arm. So notice we're getting the same format that I mentioned before of these arms, where it's R and AWS, the service, the region, the user ID, and then the ID of within the service. So we've got that. I don't know if that's going to show up over here or not. Let's see. Yep, there's our taquito service. Oh, that's because I'm in the wrong one. Here we go. That's not the target task. There's the task. So there's our task definition. It's compatible with EC2. And container. So it's where does it tell us? Should just be racist.
It's cute.
Okay, so we've set up the cluster, we're just not seeing it running yet. And the task is there, service is there, active. Okay. Well, they got it created. I'm just not seeing it running publicly.
So where are you trying to get the public ID from?
Just from the web.
Just from your laptop?
Yeah,
And you got the public ID from the
EC2 box.
from the instance, described instance?
Yeah.
Okay.
Why is it doing that? Yeah, it's not connected. That's where it should be. All the pieces are connected.
Try putting your region after the EC2 identifier. Do this after, so it's identifier.region.compute, remove the one after compute. No, still not getting to it.
Yeah. Oh, they're there, they show up in the console, but they're just not they're just not publicly accessible for some reason.
Okay, I saw a couple people on the Slack channel though were able to get all the way through this.
Cool. I might have just missed something.
Is that true? So that people got through it, and they found out that we did not have Dynamo set up in this, and that was sort of intentional. It was meant to be just a walkthrough of how it looks to actually build and deploy this sort of infrastructure. Obviously, you probably wouldn't want to build and just deploy this kind of infrastructure manually using the command line every single time.
No.
Yep, because that would be a pain in the ass. Yeah, Josh.
There, if you add the Amazon DynamoDB full access policy back in like step 4-ish or so, then the whole thing does work. It addresses the issue that.
Great.
It's entirely possible that like it's trying to connect to that in the container and it's not.
Yeah,
it's not.
it's just puking, but.
Yeah, but so, thank you, yes. We did not include the Dynamo stuff originally because like I was saying, we were just trying to get something to show this is what happens when you get a Docker image and it deploys. And what I was getting to was, so the command line is just a way to learn some of this, but the way that we actually do this in our practices currently is to use Terraform to build this. Do you want to talk for a second about Terraform?
Sure. I don't know that I should show it. I think I show
No, and we're going to try to do our wrap up in like 5 minutes.
Yeah, exactly. So Terraform is I've talked about this a few times now internally. Terraform is a config file language that mirrors all the commands that you can run in AWS, and it's built against the SDK for, it's basically, if you've heard the term infrastructure as code, so you define your infrastructure that you're going to run against a whole project or a company, whatever, within source code. So you can use source control like GitHub that defines your whole infrastructure. And basically it matches all these commands, so all the things we put in here, you just mirror that into the Terraform syntax. The nice thing about it is the areas where we did things like copy and paste or public IP or copy and paste instance ID, these are all variables within Terraform because it does interpolation, so you don't have to track that yourself. You just write it in your Terraform and say, when you create this module, grab the variable and use it here. And then you just do Terraform apply, and it builds your infrastructure. It also tears it down. So one of the things you do at the end of this is tear down your infrastructure so you're not paying for it because you're in the free tier. With Terraform, you say Terraform destroy, and then everything you can find within your Terraform file, it goes in and kills it all. So it's a really nice way to work with things like that. It takes away the need to poke and hunt around the console, but it also takes away this like command line. I have to run this command every time I want to do something. It gives some control within the team for infrastructure. So I can define infrastructure. Justin can go debug his program, realize it takes a little too long or needs a little more memory. He can do a PR against that instance and say, update the memory, do a PR, we approve it, merge it, deploy it, and your team is actively involved in your infrastructure. That also allows you to see when did we make that change, or what did we make that change, things like that. So it's sort of the DevOps way to deal with all this stuff.
I'm sorry. So your Terraform is in GitHub then, but the PR thing.
It is, but it's a private item. It's a priority hook. That's really a choice you can make. We have some IDs in some of our Terraform because of what Christina alluded to earlier, where we assume roles. So in some cases, we have to do things where, because we're developers, we have to have in Terraform assume a role that's allowed to do stuff because our normal user accounts aren't.
Is there a Terraform equivalent of like Ansible Vault that'll just encrypt stuff for you so you can put it up in
It's not Terraform, but it's within AWS. There is a vault for that stuff. Yes.
Okay.
And that's more of a best practice. We're getting off the ground with a lot of this, but yeah. We're actually pushing our ops team very much within our Rialto project on these things because it's new to them.
Okay, if you have like a public Terraform like repo that people are actually using that you can point me to, I would love to see one just so I can take a look.
You can see our modules. You can't see our actual Terraform.
Okay.
Yeah. But we do modules and stuff because you can do the same thing. The nice thing about Terraform is very program language-like in that you can say, oh, every time we want to spin up an EC2 instance, we've got to do this, 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 and this. So you don't need to tell all your devs to learn all those pieces of Terraform. You can tell your devs, use this module, and all you do is send it a couple things, and it knows all those pieces. Right.
Okay.
I also throw in, if you're not specifically on AWS, I know HoppyCorp has a Vault product, which is also another encrypted sort of tool to use with Terraform and such.
Okay.
We're using it right now, but I think we're thinking of moving away from it for various reasons. Okay, I think we're at our wrap-up step.
So, yeah, and when we jump into that, go to the next slide. Sorry, I'm going to ask you to be my man away. Oh, yeah, next one. No. Thank you. There is a bazillion slides I put in here so you can tear all the shit down that you just did. You need to do it in this order, otherwise it'll give you errors. Don't leave it up because after 6 months they will randomly show up with a $5 bill, which is not too much, but like it's annoying. Those are here, and I'm happy to walk through them with you as a group or later, but I'm hoping that you can just have these, go through it, and we can spend that last half an hour sort of doing a review of this end-to-end process we went through today and think about some feedback or questions, things we haven't explicitly gotten to yet, like serverless versus not, or some of the early questions we had in data specification, seeing how it might relate to some of the issues or questions we would have with setting up like a DynamoDB table in a readily accessible way that can support the indices that we need. So how it all connects together, having done this end-to-end process. Does that sound good to everyone? So I'm going to ask everyone to actually stand up for a second and stretch. This is the 7th inning stretch. Please, it's going to change the energy of the room. I'm not going to sing, take me out of the baseball game or anything like that, but we can do a stretch. We made it all the way through. Good job, everyone.
Are there people going to run around? We're going to have like who wins the coach?
Oh no, I need to find like the dress up like with, we have like the former players. No, Oakland has the former players where they have the big heads and they'll do the race around the track. Yeah. I could do that, yeah. Okay, yeah, thank you. So is everyone all right with saying this tear down your AWS stuff is there for you to copy the commands and walk through, and I am happy to help you, or we can help you on the Slack channel if need be. We're all good. Some of you guys were further ahead, some of you guys were with us, so like, it should be there. Okay, conclusion and retro. One of the things that we do in our projects and work cycles, developing stuff like this, is we have the idea of a retrospective. I'm sure you guys have heard about this before, but it's where we take a step back and think about what we've done today at a meta level and how it could be improved in the future, what are some takeaways that have been helpful, basically a plus delta. I'm going to ask for you to consider and throw some ideas out here for that on this workshop. And there's a couple different levels here. One is the workshop, overall. This format's kind of weird. Workshops tend to do a deep dive in one thing, not 20 million surface skims. So is it working? Is it not working? What are some functional things? Could we have more breaks, less breaks, whatever? So stuff about the workshop itself, because if we do, or if someone else wants to offer it, it's like I said, take it, make it your own. You can improve it. And then plus deltas or feedback on what you actually saw today. Development practices you're trying to set up. Trying to have the tooling that we've selected. Going with Go or Terraform or CircleCI or AWS ECS instead of like a bunch of lambdas. And any other, meta level that you might throw out there for this day. So I want to take maybe 10-15 minutes to just get your feedback, think about it. And then after that will be some open discussion questions that I heard throughout the day, but we haven't explicitly gotten to yet. All right, so thinking caps. Yes, thank you for being the first.
I actually liked that there was a broad overview. I thought the opening section where we kind of went over how things are set up, why it didn't work, and what you plan to fix it was useful. Not only just to understand what was going on here, but to go, oh, we have a similar problem. I can steal these ideas that you're thinking of. It's very easy to steal ideas.
Cool, thank you. Great. Other plus deltas. Don't worry, we can take either. I mean, unless they're like personal, I don't want to hear that I'm stinky or something.
I thought the hands-on was good, and it was well-paced and didn't leave people behind.
Thank you, yeah, great, thanks. Yeah.
Having branches in the repository so we can follow along with the slides as we know stuff.
Oh, cool, yeah. I wasn't sure about those, but yeah, I just had the inspiration like this weekend. I was like, oh, let me try to do that. So cool, thank you. Yeah. Yeah.
The email for what we needed came out nicely in advance, which was very helpful.
Yes. Yeah, although I did realize that like some people were off Monday, so sorry about that. But yeah. Cool, thank you. Yes, advanced notice, that's one of the nice things about reusing this template, even though bits of it are still a bit clunky, is we have all of the stuff formatted, so it's easy to send out. So cool. Plus deltas on the day, on the workshop, on the content, on what we're doing with our digital repository, on the name of Taco.
How can you have a delta?
This is true. Although, Yeah, I still want to name our midframe editor litter box. It would have been good, right?
Call it Menudo.
There we go, yes. This is really helpful for us, so please do put it out there. Other plus deltas. Yeah.
Having 3 people was helpful because some people could walk around while other people talked. Having a large number of
That is
workshop presenters was nice.
absolutely. I
She
did
gave
this
us
all
by
by
herself
myself
last
in
time.
Prague.
Well, it was 2 people and 1 person failed.
Yeah.
Yeah, Josh.
I'll go with the delta that this could have been like 2 days or
Yeah.
it was, yeah. It was aggressive.
Nothing if not ambitious. Stephen,
Yeah,
yeah.
for Delta, I didn't think about this last week when I was playing with getting it set up, and it'd be kind of cool to do a Hangouts that you record, walk us through a setup, and if we're trying to follow along, we can ask questions and show you what's on our screen.
That's a great idea. I appreciate that. Yeah, that's a great idea. Yeah, Eric.
I wonder if a Vapor box could help to normalize the environments for people for certain installations and dependencies.
That's a good idea. Yeah. Cool. Thank you.
And also that guy coughing to that is very distracting. There's going to keep people like that.
Ben's left. What are you talking about now?
So I just put farm mature as a dog.
No, it was Eric.
I held back your cough after saying that word.
I'll throw out another plus. Having the Slack channel was very helpful.
Yeah.
That was really helpful to see people like posting commands or otherwise giving feedback.
I was worried it would be too distracting, but yeah, I think it ended up being really useful. So I'm glad to see that. Thank you guys for taking part in that.
So sort of tying those 2 together with the fact that the person not presenting was on the Slack channel. So like someone watching Slack, presenter watching Slack.
I will say I heard some feedback, this is in the Delta column, about instead of trying to simplify it and use taquito, just go full-blown taco. I still have concerns about it would be too aggressive, but it's an idea, and I like that idea to consider. And yeah.
I think maybe a variant on that would be having some of the steps be like a little bit more templated out, which I know is a lot more work, but like the initial dive into the Swagger, add to this spec. Maybe, like I know in the software carpentry lessons, they've worked on that a lot, like trying to lead but not like too much hand holding, and I know that's a tough dance.
Yeah.
But I think that was like a big, or an example, like a big jump in, and you could have maybe
That's a great point.
templated out a little more.
Absolutely. Thank you for that. Yeah.
I would say in the deltas, I would maybe just do a little bit higher overview of like what a Go, the structure of a Go project in terms of like, I still don't know if Go is like MVC or, and obviously it's not, but like something that kind of sort of paradigms it out in terms of like, files in this directory, do this. We sort of like looked at certain things. So you did sort of a little bit, but I feel like looking at a Go project, I wouldn't necessarily know like
So I think specifically that would be a Go Swagger project.
Yeah.
Or even just like go through that Golang tutorial on their website in advance, like you can list that as a prereq, just like, just to wrap your head around the basics instead of you trying to teach it.
Yeah, in 5 minutes.
Yeah.
Here's Go, just like Ruby, but
Better. Yeah.
I recognize this falls into something to change your specific question. Trying to understand the implications of the intersection of Docker and AWS for storage. You're talking about storing something like, files, blobs, whatever, like S3. What does that look like in terms of how it affects Go, what you're doing with Go?
It's a good point, and that's maybe something, I don't want to put too much, interpret it too much, so coming back to my input. That's maybe something that would be clear if we had just gone Google and Taco, and we would have had to not just set up an ECS instance, but DynamoDB connections, S3 and S3 connections, lookups to external authorization identifier servers, all of that sort of stuff. But it's a good point. Yeah, make those connections easier to see. And this is not, I mean, this came up last time. It's going to keep coming up on the Delta side, but we really can't affect it too much. I learn a lot by doing the command line via AWS, because you actually have to sit there and learn what the hell is going on. But it's not how anyone ever interacts with it. I mean, in production systems. So I'm always torn between how do we, using your phrasing, how do we template that out? Because we can't, like, Terraform would be a whole day.
Yeah.
Right.
I'll kind of say I prefer the command line, just because I get really antsy whenever people use Terraform or Ansible. It's like, it does this thing.
Yeah.
How? How does it do it?
Or even just the console. Like, you have a lot of stuff that gets set up in the AWS console that you don't necessarily see. So I feel like I've learned AWS by starting, a year and a half, 2 years ago, just going, all right, I'm going to start with command line, because I push these buttons in console, and then all of a sudden I'm like, why can't I kill this thing? I thought I killed it, but it keeps spinning up, but it's attached to something. What do you mean it's attached to something? Who spun that up? Oh, what up? It was auto-generated? What? So I appreciate that feedback. That's something I struggle with too, on how to frame it here, because I think it's important, but it's hard.
Just show of hands, who's had a little bit of playing around in AWS console to start stuff up?
I mean, on the console version as opposed to.
The console. Like,
That's
so
the website.
The website, right? So you realize like quickly you have a sea of tabs that ends up open because everything you click opens up in a new tab, and then you don't know where you change something and say something. So the command line is a really nice way to learn without getting lost in that sort of sea of tabs.
And on a positive side, even though I wasn't able to do this because of how my account was set up, I was able to go back and look at the README. Oh, I know what's going on here.
Yep.
So it was, and I appreciated how clear that was.
Great, thank you. Any other feedback? Oh yeah.
One more plus that came to mind. I liked how the three of you alternated as presenters.
Yay, thank you.
Kind of changes the energy a little bit throughout the day.
That's true. Anything else? All right, thank you. Yeah, yay. So in parting, I'm gonna just throw this out here. We really appreciate you being in this workshop. Like, we really do appreciate you. Every time we go through this, we even like clarify for ourselves a little bit more what the hell we're trying to do. So we really appreciate it. As you can see, a lot of this is still moving targets and best practices. I would especially put a call out to you guys. Please give us any feedback you have on how we're approaching this. Like, we need to get outside of our Stanford echo chamber. I would love any feedback you have. I don't really think Taco might work this way. I'm uncertain about these data models. I'm curious about having these interface specifications. What do you really mean going with the best practice of dev role profiles? Anything like that, anything we would really, really love.
Do you think a bunch of microservices is the most robust way to handle this transition and move? Or do you run the risk of just having a lot of tiny things that start to interrelate and become a monolith by accident?
Well, so that's what we have currently.
Yeah, right.
That's what we have currently. We have 106 code bases.
Right, so what?
Aren't those all microservices?
So I think,
One of the things really quickly I would add to that, we are going microservices-ish. But the focus in my mind is not so much on making a bunch of small services, but making really, really clear interfaces and expectations. And we had a really good call with David Brunton at Library of Congress.
Okay.
He's in their digital systems services, something like that. And they actually just renamed and reorged their department to just be services. They're like, they're not micro, they're not macro, they're just clearly delineated services. And I thought that was a really interesting point. I think that's sort of what we're thinking about, but unfortunately we're going to have to be rather small to even start to migrate some of this stuff. So it's an evolution, but yes, point well taken. We do not want to end up with what we have currently. Just in go. Yeah, Eric.
Have you run into any bottlenecks so far with microservices as far as interacting between them over REST APIs rather than direct calls, or are you under your limits so far?
Have we encountered what?
Have you run into any, I know earlier you were talking about the difference between you could have like a REST API microservice, a bunch of them where you could have more direct calls, which might have better performance. Have you actually run into any bottlenecks so far as a result of the REST API?
It's a good question. I mean, the performance is not ideal for the ones that we have currently. But the performance usually is not the main issues with the one. We do have REST. We do have a microservices thing that started 10 years ago and became its current mess. The biggest issue with those endpoints for our current system has been availability, uptime, and just network flakiness, which is a variation of issues, some of which we can manage, some of which we can't because it's on-premise and the network's configuration is largely because to UIT. But that's a good point. I'm trying to keep some documentation on that. Where profiling is a set of practices, like we've not been the best at profiling because currently we have such a jumbled system, it gets very hard to profile components. You can just be like, well, I came in here and it went out there and it was slow. I'm hoping that's something we can change. It's something we prioritize for the prototype. And so as we implement stuff, we're hoping to get those numbers. And one of the reasons for something like ECS is horizontal scalability as well, which we can't do right now.
Yeah, it's been so helpful hearing about this stuff because I and probably many other people are facing exactly this kind of thing. Which way do we go? And it's really helpful. So thank you.
Yeah. Cool, thank you. So yes, all of this feedback is great. Put it in the Slack channel. You can use that taco workshop. We'll be monitoring it. You can contact one of us directly if you like. Email, Slack, whatever. I'm 18,000 behind on emails, so I might not respond right away, but you can totally email. And we would really, really love to have your input on this. Stop us at Samvera. And then any other questions we have remaining, just given the time, I am going to say stay on the taco workshop Slack throughout the week. And let's raise those there so we can have discussions and invite other people. And we keep discussing. But yeah, and Justin, Aaron, anything else to say? Yeah, thank you guys so much for taking part. Yay, you got through your first day of Samvera.